Hi, today we will use Python to test Benford's law on a dataset. As a first step, we will try to load the necessary libraries, pandas, numpy, plotly for visualizations. Once we load those libraries, we can use the functionalities of those libraries as we explore the dataset. So let us go ahead and run that cell so that those libraries will be loaded into the system so that we can use them in our exploration of the data. So let's run that. Once we run that, those libraries are loaded now. And now that we have those libraries, we can go ahead and look at what is the data. It's like I said, the data is DC government purchase card transactions data, which is available as open data. So I can leave the link to the in the description box below. And if we can also look at briefly what is the data is all about. So let me pull that data window onto the screen, and here is the window, and we can see that this is a DC government purchase card transaction data, which has about 584,709 records. This keeps updating periodically, so obviously those numbers might differ when you see this try to load this data at a future date. We are interested in the transaction amount column so that we can extract the leftmost digit and test Benford's law on it. So if you haven't done already, please go ahead and download the dataset. And once you download, come back to this video and let us try to load that into Python. We'll use pandas, pandas function read CSV, and we'll pass that file location. So that that will be saved in variable df. So once we run that cell, the data is loaded into the system. And once we have the data, let us try exploring the data. We have to first understand what are the various kind of columns. Though we have seen briefly the original data set, now that we have loaded, we can look at the sample, random sample. Those are your columns. And this is the transaction amount column, which we wanted to target and try to extract the leftmost digit from the transaction amount column. And there are other columns too. So let us first see what is the shape of the data. So once you run this cell, we'll get the shape of the data. It says 574,806 are the rows. First are the rows and second is the columns. So rows, and there are 8 columns in this data. And let us try to get the information about the data set, which has, which will tell you what type of data types are available in the data. Like as you can see, there are various objects which are kind of dimensions or string data types, and we have float, which is the transaction amount, and we also have object ID as a integer. So those are the various descriptions. We have the info about the data set. Let us go to the next step. Let us try to look at the summary statistics. Once we have decided that transaction amount is the column. So let us see the summary statistics. We have the mean, standard, min, and all those quartiles and max. So again, it says data type is float 64, which we have already noticed in the previous step. And once we have that, let us try to kind of do a brief EDA, explore the data. And let us try to count the number of agencies. We'll try to get the 10 agencies because we want to have a visualization, because if we try to bring all the agencies, the visualization doesn't look good. So we'll use the value counts function. We'll use df agency.value counts. That will give you the count, and we'll try to get only the 10. So that we have those agencies up here. And next step is to purely use plotly expresses bar function. and give the X and Y. In this case, we'll give the number of agencies index as the X value, and for Y, we'll give the number of agencies values. And in case if you want, you can add the color too. I've added the color argument too, and we can update the layout. We can give the Y-axis and X-axis title, and we can say that we don't want to see the legend. And fig.show will give you will show you the plotly bar plot here. If you can scroll down, we should be able to see the top 10 agencies. So those are the number of agencies like District of Columbia Public Schools. Those are the, in the transactions, they have used it to buy stuff from various vendors. Similarly, we'll also do for vendors. We'll try to get 10 vendors bar plot, and same way we will try to pass the value counts. We'll try to use value counts and visualize, and Amazon Marketplace, and those are in the transaction set. So those are the maximum vendors, and also we'll see what is the total amount, transaction amount. And we can see that this is about 381 million. Of course, this is for a long period, so they might have used those funds to buy stuff. So we have to look at the timeline, then we'll understand. And we wanted to see what are the columns. Those are the columns. And once we display one sample, we have those agencies. So when we try to create a new column, leading digit, so it is a good idea for us to move the transaction amount column to the end of this data frame, so that it will be easy for us to compare with the leading digit and this transaction amount. So let us use list comprehensions. As you can see here, we can use list comprehensions so that we'll move transaction amount column to the end. It's a very simple code. So let us try to go ahead and run that particular code. I have briefly written the explanation also, the code. And once we run that cell, we have that leading transaction amount to the end. So now that we have done this step, the next most important step is that we have to extract the leftmost digit from this column. Right? This is the method which we follow. We try to create a new column, df leading digit, and we'll go to the transaction amount, and first we will cast our transaction amount column data type to a string, and by using the string accessor methods which are available, we'll try to grab a leftmost character. Remember, in Excel and Power BI we have used left, so since pandas, I don't think so they have a left function, as we are kind of using this method. Once we extract that, and finally we store the result in a new column, and we'll try to filter out any zeros, so that way we have a new column in the data frame. Let us go ahead and run that cell. And important thing is that we have to test out whether our method worked or not. So I'm trying to use take some samples, like for example, if you see here, those are the samples with 2, 3, 1, 5 and 4 as the leading digits. Once we use the same method, we will see that that is perfectly working. 2, 3, 1, 5, 4. That means our leading digits from the transaction columns are accurate. So now that this particular logic is behind us, we'll go ahead and try to run those two columns separately so that we can do the comparison. Once we do that, as we can see, 1, 2, 4, 1, 2, 4 on the right, those are checked out. Now that we have done this step, next step is logical, is that we have to find out the frequencies, and we'll go ahead and use the value counts column, and we'll sort index, so that will be from higher to lower, and we'll store that in observed. And once we run this particular cell, we should be able to get the frequency of each and every digit. As you can see rightly, we have those frequencies. As you can see, 1, 2, 3, 4, they have the respective frequencies of 168, 74, 106, 516 and 66, 912 and so on. Now that this step is completed, we have to go to the next step. So, but before that, we want to make sure we have the unique digits. So let us go ahead and using the unique function, let us try to run this cell so that we'll get those unique digits. Yes, those are 1 to 9. So we are good. Now that we have done, next step is that we have to create a Benford distribution so that we can do comparisons with observed and Benford. We already know the formula log 10 1 plus 1 by digits will give you the probability of each digit. So let us go ahead and store that in dist and run that cell. As expected, the distribution is exactly what Benford's law says. So now that we will try to create a new pandas data frame. We'll pass these observed and distributions to that. Once we run that column, we should have those things already. We have those observed and distribution as shown here. So once we run that cell, we can scroll down. We can see that those frequencies are there for observed and the percentages for Benford. But as we can see here rightly, we have frequency for observed, but percentage for Benford. So I think we have to do another step here. We have to first calculate the total sum on the observed column and try to divide, say for example, 168.74 over that sum, the total, and 106.516 over that total should give us the percentage. So let us go ahead and see what is the total grand total. We know that it's 548,957. So the next step is 168.74 over 548,957 and 106.516 over 548,957 and so on. So that if we do that step, we should get both observed and Benford in percentages. So it's a very simple thing. Let us go ahead and calculate that in this cell. We have that observed, and we observed dot sum will give us the total like in the previous step. So that total is already here. So once we run this, now that observed and Benford have the same type of data, both are percentages. Now we are happy. The last logical step is that we have to visualize it so that this will be like a Benford distribution thing. On the x-axis we have leading digits. On the y-axis we have those frequency distributions in percentage. So we can use the Plotly express bar function. We'll first pass the data. For x, we'll give you the digits, x-axis, and for y, we'll give two columns, observed and Benford, and we'll make the bar mode as group so that both the values will appear next to each other. And I've also given some color so that those things will pop out. And the next few lines of code is how you format, how you want your y-axis to show up. It is percentage, and we try to change the category x-axis category as x-axis as a category type, and give x-axis title leading digit. And once we run this cell, we should be able to get those comparisons. Yeah, perfect. Now we see on the left we have observed. On the right we have those Benfords. So this is an interactive bar chart so that you can click on those variables and see only those variables which you want to. For example, let us click on this. We want to disable Benford, and we can see only those things observed are available here. So we can play around with it so that the interactive feature is also being used. Now that we have achieved whatever we have intended to, we have used Python and simply ran a couple of cells, and we have calculated. We have in fact tested Benford's law on this, and also you can use Streamlit, which is open source library from which can be used in Python. So go ahead, in case if you're aware of it, Streamlit, it should be easy for you. And this is how I did the Streamlit part. So we have done the same steps, shape of data and summary statistics and sort of. And if we scroll down, more steps are visible. And you can just run each line as you type into the Python file. Those things will be visible. Now that it's a complete file which I ran, so all those things are visible here. But as you try to build a Streamlit app, every chunk of code you can run so that those values will appear in your browser window. So let us look at it. We have done the same thing. We have moved transaction amount to the end and calculated the frequency. And we have also checked out what are the unique digits. I mean, exactly almost the same in whatever we did in Jupyter Notebook. So I'm just trying to replicate that here. We have those percentages and we have those comparisons. And once we have those comparisons, we can just go ahead and do the plot so that we have those things visually as well. And for anyone who is interested in EDA, I have just tried to run the top agencies, and also on the left sidebar you have the details about Benford's law, what it is and how the distribution looks like. This is exactly what we did now, and also it will give you what is the data. So it's a kind of handy and interactive thing. So that you can add more code also, so that you can click on it and those things will pop up in case if the code is there. Those are the things which I've done, and I can quickly show you the code too. Let me grab that code onto the window so that you can see how I did this Streamlit app. Here is the code. I will leave the link to the code in the description below. So these are the various, it looks pretty long. It's about, I think, 80, 90, yeah, about 100 lines of code, but it's pretty long. But don't worry, it is step by step, whatever exactly we did in on the previous example. That is exactly what it is. This is the last video in Benford's Law series, and see you in the next video. Thank you for watching.